Hello. So in this section, we are doing more of the work of quadratics, which we looked at last time. We looked at solving quadratic equations by factorizing and using the quadratic formula, how to use your calculator. As your calculator will also be able to solve quadratics. We looked at harder equations that we can transform into quadratics, which we call hidden or disguised quadratics. And so we looked at a bunch of equations, and some techniques for solving them. What we're going to look at now, we're going to extend our study in quadratics. It's looking at completing the square. Again, you should be familiar with this from GCSE. But essentially, what we can write a quadratic ax squared plus bx plus c into an alternative form, which is called completed square form, which will have a lot of uses. So, um, let's look at a very simple form here: x squared plus bx, right? Very simple type of quadratic. If we complete the square, then that's saying it's in this form here. So we have x plus b over 2 squared. So what we've done here is we've got our x, and then we halve the b, the coefficient of x, right? The b, we halved b, and then we subtract that number squared, so b over 2 squared. Okay, and that's generally the form. It looks really awkward, obviously, as it first in this way, just by looking at it in this way. But we're going to look at loads of examples with this in use. And so this is called completed square form. This bit on the right hand side here. And you can easily see that's true by just expanding the brackets, right? Obviously, you're going to get fractions, but don't be afraid of it. You should know how to multiply fractions. We looked at expanding brackets like this in the first chapter. So actually, this would be a good exercise to test that skill. But yeah, so essentially that's what this chapter is going to look at, right? Is writing stuff in this form and then how we can use it. Yeah. So let's have a look at some examples then with this in action, because this looks a bit waffly, right? Just a bit of random writing, right? Random algebra, right? Let's have a look at this in action, because I think it's a lot easier to see with practice. Okay, so part A, we need to complete the square for the following. So we have x squared plus 8x. So if we were to follow this idea, which we wrote down at the start here, so we're going to write it as a bracket of x plus b over 2. So that's halving the coefficient 8, right? So half of 8 is plus 4 squared. Then I said I take away this number in the bracket. So take away 4, but then I'm squaring the 4, so it'd be minus 4 squared, and then I could simplify it, right? Because then x plus 4 squared minus 16, because the 4 squared is 16, and that is completed square form. Okay, the whole idea is we try to get rid of these x's. So there's two x's, right? We have an x squared term and an x term. The whole idea of the complete square form is to put just one single x, right? Which is in this bracket here. And again, you can see that's true. Let me just show it's true for this case. But you know it's true because you can expand the brackets and you'll get back the original. So if I was to expand it, well, x plus 4 squared, that's x plus 4, x plus 4, and we have minus 16. So that is, well, if I expand, it's going to be x squared plus 4x plus another 4x, that'd be 8x, and then plus 16. Take away 16, well, they the 16s cancel each other out. So I'm left with x squared plus 8x. So there we are. Um, so we can write it in this form there. Okay, and then also, Jen, if you are a bit stuck, oh, did I write it in the right form? Remember, you can always expand your answer and then go the other way to see that it's true. So if you expand it like I just did, you should get back the original expression. Okay, part B, we have x squared minus 3x. Again, I'm going to do the same thing. So I have a bracket of x, and then I'm halving it, so -3, but then I'm halving it to be over 2 squared. Then I'll do -3/2 so then I minus this number, so -3/2, and square that. And so if I do that, I have x -3/2 squared. And then, well, -3/2 squared would be positive 9/4. Right, because 3 squared is 9, 2 squared is 4, so positive 9/4. But then I'm minusing it out because I have a minus outside the bracket, right? So it'd be -9/4, okay? And so in general, you should always be subtracting the number outside, right? Um, See, look here, right? There's a minus there. So this will be a square number, so that'll always be positive. But I'm subtracting or doing the minus of a positive number, so it would be negative, right? So you should always be subtracting, no matter if the number inside the bracket is positive or negative. You should always be having the negative outside the bracket. Okay. So you might think, well, -3/2. Well, you might think from -3/2 squared is 9/4. So there we are. It's just plus 9/4. That's not what we're doing. We put plus 9/4, but then we have to put a minus outside. Okay. Part C. Um, let me scroll up. Okay, now we have 2x squared plus 12x. Now it's a little bit more of a step up because this time we have a number in front of the x squared. So it doesn't work in the same way of just putting x down. So what can we do instead to kind of get it back into the form in like A and B where we've just x squared plus some lots of x? So we only have one x squared, but we have two here. How can we do that? Well, we just factor a 2 out, can't we? We can factor the number out. We say it's 2 lots of x squared and then 6x, right? If I factor 2 out to both terms. But then what can I do here? Now I have a nice form that I know how to work with, like in part A and B. It's just 1x squared. I can complete the square in this of this part of the bracket, right? Inside. So I have 2, and then if I complete the square inside of the x squared plus 6x, well then that'll be a bracket of x. And then half of 6, which would be plus 3, all squared. And then I take away the square, which would be 3 squared, would be 9. Um, and then I can just, at the end, I can then just times 2 to everything. So then 2 lots of x plus 3 squared. So I'm expanding the bracket, right? So 2 lots of 3 plus 3 squared. And then I'll do 2 times the -9, that'd be -18. And there we are. It's in the same sort of form now, right? To part A and B. Yeah, there we are. Just have a number in front, but that's fine. Um, and yeah, that's basically completing the square. And you can see there, as long as we know how to work with a quadratic that's like x squared plus bx, we can kind of adjust it for other quadratics. So, for instance, like we saw in part C, if we have a number of the x squared, we could just factor that out to then just be left with 2 lots of x squared plus 6x, right? And then we can work from there. But that's complete the square, right? Not to overcomplicate it, but that's the whole method, right? That's all what they will be doing in this section. That's all that we'll be doing. So have a look at another example then. So we have 3x squared plus 6x plus 1. Okay, now we got a proper quadratic, right? So here we have a number in front again of the x squared, but we also add in something. We add plus 1. Well, we want to complete the square on the x squared the next part, right? Because remember, complete the square, we do it for x squared plus bx, right? Uh, well, see what I can do here. Again, like with the last example, we can factor the 3 out, can't we? To then just get x squared. So we have 3 lots of x squared, and then 6 will be 2. Because then if I factor 3 from 2, I get 2. 3 from 6, I get 2. 3 times 2 is 6. But then I'm just going to leave the plus 1 outside. Because this number, put at the end, if you see in this way, that's this whole expression. And then I'm just adding 1 at the end. So I can just put that outside and deal with that later. So really, then I can. That's how then you adjust for the added like numbers that we've got. And so yeah, now we can complete the square on the in the inner part that we know how to deal with, the inner expression. So we have 3, and then we complete the square inside the bracket. So that'll be x plus 2 over half of 2, which should be 1 squared. Then I'm taking away 1 squared, which should just be 1. And then I have a plus 1 outside. Then I'm going to expand the brackets to get rid of it now. So we have 3, lots of x plus 1 squared. Then we have 3 times minus 1, that'd be minus 3, add 1. And I can simplify that a bit more because I have 2 numbers here. Minus 3 add 1 is minus 2. And there we are. And you can notice then we got our answer in this form here. So we have a number p, which should be 3 if we compare. So p would be 3 in this case. Q, x plus q, well, q is clearly 1. And then we have a number r outside the brackets, which will be this minus 2 here. And there we are. We got it in this form here. And again, to reiterate, this particular form here is again called completed square form, just to echo that. And that's it. Cool. And so in general, when you see like we have a quadratic and then we get some sort of bracket x plus something squared, that hints that you need to complete the square. Okay. Uh, but um, but yeah, again, that's the whole process, right? So if we want to if we have a number for the x squared, we factor that number out, and then we have a number at the end, well, we just tap that number on after. So really, the whole idea is we kind of complete the square of this bit inside, and then we go from there. Okay, have a look at another example to really reinforce what we've done. So we have 2 plus 0.8x minus 0.04x squared. Now, I'm not too comfortable, I don't know, with that. The number in front, it's a bit of a weird order. I can just simply rearrange to get minus 0.04x squared, add 0.8x of 2 instead. I feel like some people might have found that a lot easier to visualize what I need to do, right? So you can always do that. Um, and yeah, and this example, again, I have, it's the same sort of examples. Last time, just a bit more awkward numbers. Now, will be important for when we do the modelling later on. So modelling meaning we work with real life situations involving quadratics. So real life, you're not going to get nice numbers, but the whole idea is essentially the same. We need to complete the square. And we can use the exact same sort of idea as last time. Firstly, we can factor to get just x squared. I can factor a minus 0.04 out. So that'd be x squared. Then I need to work out what I need to factor I need to somehow deal with the zero point 0.8 with the minus 0.04. How am I going to work out how to factor minus 0.04 from zero point 0.8? Well, if you think about I have a number here, so bx, right? Well, I'm going to have to multiply these two numbers together, b and 0.04, to get 0.8. Okay, so to work that out without having to struggle too much, I can just say, well, this number b times by 0.04, which 0.04b would be equal 0.8. Therefore, our number we need to work out to put in the bracket, which would be 0.8 divided by minus 0.04. And so if you work that out on the calculator, that would be 20. So it'd be minus 20. So that we can put in here. Cool. And then we add this plus 2 at the end, right? We don't need to worry about that's just a number we add on at the end. And so, whilst we've got the numbers are not as nice this time, we've still got it in this form now that we know how to work with it. We know how to complete the square because now we do no minus 0.04. Then we complete the square inside here. So again, we're gonna have x, and then we're gonna halve this number here. So we're gonna that would be minus 20x. Sorry. So then half that'd be minus 10 all squared. Then then I'm going to do negative of the square number. Well, 10 squared be 100, so we have minus 100. And then we add the 2 on at the end, right? Now, again, we're going to expand it. So we have times minus 0.04 with everything inside the bracket here. So we're going to have minus 0.04 of x minus 10 all squared. Then I'm going to do minus 0.04 times minus 100. So if we do that calculation, we get 4. And then we're going to have this plus 2 at the end, remember, which we expanded. Lastly, we can pull all that together by doing 4 add 2. We get minus 0.04 of x minus 10 all squared plus 6. And there we are. And you notice, well, we can rearrange it, but it's not exactly in this form because it's saying we have a number, take away the bracket. So the number is plus 6, right? So we can rewrite this and change the order in, right? I'll just say, well, instead, we have 6 minus 0.04 of x minus 10 squared. And then we exactly match what the answer, the form the answer wants us to write it in, right? So A, then, if we match it, A would be 6, right? Here and here. Then we have this minus B, this number outside the bracket. Well, that's minus 0.04, so B would be 0.04. And C, again, we have x plus C inside the bracket. Well, C and minus 10, well, C has to be minus 10. And there we are. Cool. And again, I notice I need to complete the square because I have x plus something squared. Okay, that's hinting to me I need to complete the square. Okay. So yeah. So again, exact same procedure. The numbers weren't as nice this time. But we will see other examples later on in the chapter. How to deal with this sort of thing. But that's the whole philosophy, right? Nothing new there. Exactly to complete the square like we normally do. But yeah. Cool. I'd say probably the hardest thing is spotting how to factor out the minus 0.04. And again, you don't have to worry too much if you realize, well, if I have minus 20x here, but if I had like, well, that's clearly going to be x squared with some lots of x, right? Then I can expand that out, right? And then say, well, that has to be 0.08. So b times 0.04 is what 0.8, and therefore it gives me the way the number to factorize in, right? Which was minus 20. Okay. If we can write that back in, that's minus 20. Okay, cool. Okay, so that's complete the square. So we should have a good idea how to complete the square now. Hopefully it's a good refresher from GCSE. But we can also go a step further and solve quadratic equations using completing the square. So let's have a look at that then. So first it's asking us to solve the equation x squared plus 8x plus 10 equals 0 by completing the square. Well, obviously the first step is going to be to complete the square on this quadratic, right? Well, actually, we don't have a number in front of the x squared, so we can literally jump right in and complete the square on the x part, right? So that'll be x plus half of 8, which would be plus 4, all squared. Then take away 4 squared, that'd be take away 16. And then we have this plus 10 at the end. And so after, if we, and that'd be equal to 0, right? And so we have x plus 4 squared. To deal with the numbers, we have minus 6 equals 0. Now, we can solve this, right? Because notice I have a square number, right? I have something squared. If I actually I can move the 6 around. Because remember, the whole strategy is to get x on its own. So I want to move everything else not involved with x to the right. So let's move this 6 to the right hand side. So I'm going to have x plus 4 squared equals 6. And hopefully now you can spot, well, x plus 4 is a number, and we have something squared, right? Something squared equals a number. I can square root both sides, right? Again, exactly like an equation we looked at solving last time. So simply then, x plus 4, if we then square root both sides, x plus 4 is going to be plus or minus the root of 6. Remember, plus or minus because it's solving. So when you square root, when solving, you need to do a plus or minus. Because of the fact that a minus will square to get us the same number as a positive. Okay. Anyway, so you have plus or minus 6. And then, well, to get x on its own, to solve it, well, move the 4 to the other side. So subtract 4, so then x is minus 4 plus or minus root 6. So our two answers, our two solutions are x is minus 4 plus root 6 and x is minus 4 minus root 6. And there we are. So, and it asks us to give it in third form. So, don't convert to a decimal. This is third form, okay? Again, we might also call this exact form as well, meaning that that's the entire answer, right? Without having to then convert to a decimal or anything like that. Because if you write that as a decimal, remember root 6 is a third, so it'd be irrational. So it'd be a forever going to a decimal. So we can't physically write down the answer in its entirety if we were to write it as a decimal. Anyway, so that's our two answers, and hopefully then the idea is if we complete the square, but I'm going to have something squared equals a number. So then I can square root, essentially. And that's how we can solve it. Let's have a look at another example then. This time we need to solve the equation 2x squared minus 8x plus 7 is 0. Exactly the same process. But if we complete the square, well, complete the square firstly. So I notice I have 2 in front of the x squared, so I want to get factors out. So I'm going to have 2 lots of x squared and minus, well, 4x, and then have the 7 outside because I'm only dealing with the x part. Because I'm going to complete the square on the x parts, and then I can add the 7 on at the end. Okay, so that's what I'm going to do. So I'm going to have 2 lots of, and then I complete the square inside here. So that's going to be another bracket x minus, well, half of minus 4, that would be minus 2 all squared. Then I'm going to do minus of the 2 squared, right? So it'd be minus 4, another bracket plus 7 equals 0. Okay, now I'm going to expand it. So then I'm going to have 2 of x minus 2 squared, and then I'm going to have 2 times minus 4, that'd be minus 8 plus 7. But then if I then simplify, I can add the numbers together to simplify. Then I'm going to have 2 lots of x minus 2 all squared. Well, minus 8 plus 7 is minus 1. But actually, if that equals 0, then simply 2 lots of x minus 2 squared is going to equal 1 if we add 1 to both sides afterwards. And yeah, well, then now we can solve for x. And again, I'm going to get x on its own. So the first thing, let's get rid of this 2. So I can divide by 2 to both sides. So I'm going to have x minus 2 squared is 1 over 2. And then I have I have a square number, right? I have something squared equals something. So I can square root to get x. So then x minus 2 is going to be plus or minus the square root of a half. Okay. And then simply to get x then, we can add 2. So then x is 2 plus or minus root of a half. And there we are. That's our answer. Yes, it says give our answers in third form. So again, keep the thirds. We could simplify it a little bit, right? If you remember our third law, back to the other chapter. If we have root a over b, I can split the root up to be root a over root b instead. And then, well, if I do that, what x then would be 2 plus or minus root 1 over root 2. But root 1 is just 1. So then x would be 2 plus or minus 1 over root 2. And actually then I can rationalise the denominator, can't I? Again, think back to last chapter. We looked at rationalising. To rationalise, I want to get rid of the root. I can just times by root 2 over root 2. Because then root 2 squared is just 2. So then x is 2 plus or minus root 2 over 2. And there we are. So I guess that's a more cleaner form, but he didn't ask us to do that. I wanted that really not test them to test our skills that we learnt so far. And again, a good tip when you're doing this A level, you can revise. It's helpful to continuously keep doing, refreshing your memory, and doing examples from earlier parts of the chapter. I would not absolutely not recommend leaving everything once you did it to the very end. Ideally, once every so often, you do start to revise and go over past questions from earlier chapters. So yeah, this is a good exercise of remember it, refreshing our algebra skills, right? But anyway, that's a simplified third form, so that is our answer. Cool. And yeah, that's essentially it, right? The whole idea of completing the square, that's it. There's nothing more to it. Um, okay, but actually, so we can look at the exercise, some more questions. Okay, but actually, we can also complete the square to prove certain properties of what we have. So we can prove that it's positive, the whole expression. So n squared minus 8n plus 20. We can prove that somehow this is positive. So no matter what value of n I plug in, so I can plug in n is 1, n is 2, n is like negative 3, n is like negative a million, or anything like that, it will always give me, if I put this whole thing into a calculator, this n squared minus 8n plus 20, for any value of n, it will always be a positive number, okay? And that's what we say, greater than 0, which means it's positive. But how are we going to prove that? Well, it says complete the square, so that's a good tip. Well, firstly, complete the square then, right? So again, I have n squared minus 8n, so I can jump right in to complete the square on the n parts. So we're going to have n, and then a half of minus 8 is minus 4, all squared. Then I'm going to do minus 4 squared, which is minus 16. Then we add the 20 on, right? So then that'd be n minus 4 all squared. Then minus 16 add 20 is plus 4. So that's completed the square. But somehow, then apparently we can see that it's positive. Well, why is that? So we need to say, well, this then is greater than 0. Well, why is that? Well, that's because, well, we have a square number, right? We should know that square number is always positive. Well, actually, it's always non-negative, okay? Meaning, if we have a square number n squared, for example, that will always be at least 0. Because think about it, 0 squared would be 0. But then if we had 1 squared, that would be 1. Well, that's positive, right? But also minus 1 squared will also be positive 1. Because of the fact that a negative times a negative, because you're squaring the number, meaning you're timesing the number by itself. So negative times a negative is a positive, right? And that's essentially the reason behind this, okay? But I also want to go over this terminology. No, I'm not going to go over it now. But essentially, we have a square number. It has to be at least 0, right? It can never be negative. So, with that in mind, well, this number here, n minus 4 squared, well, it's a square number because n minus 4 is being squared. So that means this expression here has to be at least 0. So this can never be negative again because we have a square number. Again, I'm going to emphasize and echo again, a square number, n squared, in this case, n, well, it's n minus 4, right, to think inside the bracket. But this number has been squared, so it's a square number, so it's always positive or non-negative. It's not negative, right? So this has to be at least 0, this expression here, that highlighted. But, okay, but then I'm adding 4. So actually, this expression has to be at least 4. But then 4 is positive, so actually it's greater than 0, okay? And there we are, that's essentially it. So we proved that positive greater than 0 as n minus 4 squared is not, I'm going to use inequalities. As n minus 4 squared is greater at least 0, uh, and that's it essentially, because if n minus 4 squared is 0, at least 0, because it's a square number, again, look at this explanation here. Um, it's a square number, so it's not negative, so it's at least 0. So then that means if we then add in a positive number, it's still going to be positive, isn't it? So you have something positive, and then we're adding something positive, it remains positive, so it will be positive for any value. And there we are. That's essentially the reason. And that is a fairly common sort of exercise, a fairly common sort of proof. So it's a really good idea that at the back of your mind, I can use completing the square to prove that a quadratic is positive or whatever. Okay, and we have one last example to leave off from. So then we need to prove that x squared at 8x plus 20 is greater than or equal to 4. Well, here this time doesn't tell us to complete the square, but with quadratics, there's only so much we can do. We can either perhaps solve it, but the problem is, first of all, we have an inequality, not an equation. So we're not solving for a particular value. So not really. Also, it needs to be for all values of x. So if we're solving, remember solving only gives us certain values of x. So solving is out the question. Well, the only thing we really know is the factorising and complete the square, and now well, you complete the square and the quadratic formula. Factorising and complete the square to do with solving. I don't know, but we know how to complete the square. The complete square, like we just seen, will tell us something. So we can try that. And so we need to put square then into 4. Um, But actually, what you should notice is we can subtract 4 to both sides. We'll look more about inequalities later in the next chapter. But you should remember from GCSE, we can take away a number to both sides of an inequality. So then we have x squared plus 8x, and then plus 20, take away 4 is plus 16. And that will then be greater than or equal to 0. And now our objective is to prove that it's not negative, okay? So it has to be at least 0, which is a lot easier to deal with. Well, how am I going to complete the square, right? That's it. That's really the only thing I can do, really, if I'm not solving anything. So to complete the square, well, again, it's just complete the square on the x part, so it's going to be x and then half of h should be plus 4, all squared. Then I'm going to take away 4 squared, which should be minus 16. Then I'm going to have plus 16, right? This plus 16 at the end. And so then what we're left with is this becomes x plus 4 squared. Minus 16 take away 6, minus 16 add 16. So that would be 0. Well, that's just nothing. So I'm left with simply this. Well, it's a square number again. X plus 4, it's been squared. It's a square number. We've discussed up here, it has to be, again, a square number that isn't negative. So it has to be at least 0. So by definition, because it's a square number, uh, as it is a square number, that means it has to be at least 0. So it has to be greater than or equal to 0. Okay. And therefore, that's what we got. There we are. We're proving it then, right? Because if x squared plus 8x plus 20 is greater than or equal to 4, we can take the 4 away, and then we've shown that it's positive, right? This quadratic is positive, or non-negative, so it's not negative. So I'll complete the square, and then I've got this square number at the end, which has to be non-negative. It can't be negative because it's a square number. And there we are. Um, So yes, that's actually so. We can also you should bear at the back of your mind. We can use complete the square to prove how a certain quadratic can only be can be positive or can only has to it can only be so large or be so small because of the fact we have a square number. Okay, and these are and this is the sort of method to follow, right? Just complete the square, then you recognise the square number, so it can only be positive or so on. We'll look at more examples of this in later chapters, how to use complete the square, but this is essentially right, what we do, right? This is the whole idea behind it. And so, yeah, that's essentially it without waffling too much. That's complete the square. Uh, Fairly simple idea of essentially, if we go back, we have x squared plus some lots of x. We can write it in this form here. Hopefully, you know, even though the form looks a bit weird in this way, you know how to do it, right? Essentially, have an x and then halve it, and then we take away that number squared. That's essentially what we're doing. That's what this is saying. But hopefully now you understand, well, how to do it, and then how we can use that then to solve equations and then prove how something is positive or whatever. But yeah, there we are. I'll see you next time.